Federal Motor Carrier Safety Administration to discuss FMCSA, or FMCSA's programs, activities, and challenges on the commercial vehicle industry. Bill?
Thank you, King. My name is Bill Quade. I am part of the Federal Motor Carrier Safety Administration. We're part of the Department of Transportation that is responsible for making sure that trucks and buses on our highways operate safely. I'm going to talk to you today about, a little bit about the industry we regulate and some of the challenges we have and how engineering fits into it. Before I start, I'd like to find out, does anybody have any idea how many interstate truck and bus companies there are in this country? Take a guess. 3,000? Any other guesses? How many? Yeah, go ahead. 10 companies? Okay. Yeah? 100,000? We're getting closer, by the way. But you're not there yet. Yes? 500,000. Closer, but we're not there yet. There are 715,000 interstate trucking companies that move goods and people. Everything in this room probably arrived by a truck. The chairs that we're sitting on, the carpet, the beams, the concrete, the air conditioning system, everything in your grocery stores arrives by truck. Everything, everywhere, pretty much arrives by truck at some point in time. The busing system is growing more and more. The interstate busing system, as the airlines become more expensive, the bus becomes more attractive. A little bit slower, not quite as comfortable maybe, takes a little longer, but when you're on a budget, sometimes you got to take those alternatives, and I am. So, wow, 514,000 interstate motor carriers, 7 million. This is where the 7 came in. 7 million commercial drivers we regulate, 9 million large trucks. So this is a big industry we're responsible for regulating. And we're responsible for making sure that it's done safely. You can see the stats behind me. I love the graph because it's going down. That's the number, the fatality rate for commercial motor vehicles in this country, truck and bus crashes. I love the rate, okay? But the reality of it is rates aren't real. We can measure rates, and they're nice and everything, and they help us tell whether we're doing a good job. But it's the numbers on the left that are really important. Last year, there were 3,619 fatalities in commercial truck and bus crashes. That's a lot of people that are still dying. So while the graph is going in the right direction, and we're really happy about that, we still have a big challenge in order to improve our safety of our highways with respect to trucks and buses. The cost of society is huge. So one of the things I love about my job is that we are coming to work every day to improve safety, to save lives. That's what we work for. And frankly, this is something that you can get up really easy to work for. If we do our job right, then fewer people die. And so when the numbers come in at the end of the year and it says that, that is a reward that goes beyond the salaries. We have a bunch of strategies. You saw from my title at this point in time, my title is Associate Administrator for Enforcement and Program Delivery, which means that I'm responsible when trucking companies don't do things right for making sure that we sometimes have to fine them. We sometimes have to put them out of business. This is what my job did. But I came in with the agency as an engineer. And it's this use of engineering down the bottom strategy that I'm going to talk a little bit more about. Because there's a very special kind of truck that's dear to my heart called cargo tanks. These are the tanker trucks that transport gasolines to gas stations. They transport chemicals to factories. They can also transport milk or water. They kind of look like some of these pictures. The semi-trailer, big long trucks. Our agency, in addition to making sure that the drivers are qualified and the trucks are maintained, we're responsible for making sure these things are built correctly. And that takes engineering. Okay, so there you go. This is what we're trying to prevent. This is actually a picture. This truck fell apart on the Long Island Expressway, and the result of this crash was my first actual encounter with a real live congressman. I got to go up to Capitol Hill and explain to the congressman, whose wife, by the way, was stuck in the traffic jam behind this thing, what we were doing to make sure that this didn't happen. And so we've got rules and regulations that tell you how strong you have to build these cargo tanks. We rely on the American Society of Mechanical Engineers Boiler and Pressure Vessel Code, which again gives us some standards for how pressure vessels are supposed to be built. American Society of Materials is got standards. So we gather information. We go out to a company. That plate there is on the side of a truck. It's got a lot of information for us about how this truck is supposed to be built, what kind of standard they built it to, how much pressure it's going to have. We do analysis. And, you know, one of the things that I used to do was, you know, look at the designs on this truck and figure out, is the tank strong enough? And you can do hand calculations, traditional analysis to do this. Nowadays, you've got finite element analysis, which is computer programs that you can program in and to show you where the stresses are in the materials. Not only the vehicle itself, but the bumper on the back of it. We need to make sure that those bumpers are strong enough, because we don't want, if a car crashes into this vehicle, for the hazardous materials to go all over the place. You know, that can result in a lot worse damage than simply a car crash. There are devices on the top of the trucks to protect the vents and the valves in case the truck rolls over. So we're responsible for making sure whether all these things are done properly. And then there's the whole manufacturing process. Are the people putting these things together doing it right? And so we go out. One of the cool things about working for our agency is that you get to experience different things. I've been to cargo tank manufacturers in Illinois and South Dakota. It's the only time I've ever been to South Dakota. Beautiful place, by the way. And Tennessee, all over the place, all over the country I've gotten to travel in order to do this type of work. I can't boast the world travel that Mr. Stone does, but I have seen most of the country. So, you know, in the final evaluation, we're the ones making decisions as to whether or not those trucks are strong enough to be on our highways and transporting materials or not. So engineering is playing an important role, and that's kind of my overview. You know, one of the things, we talked about Facebook, the other social media, and the one I'm really into is Twitter, and I follow this group called Great Quotes. And this morning, I'm on my way over here, and I read that Gandhi said, "Persistent questioning and healthy inquisitiveness are the first requisite for acquiring learning of any kind." And for me, that is what engineering is about. More than anything else, it's about questioning and learning. It's about thinking about different ways we can do things. And one of the things King said it, we have to come up with different ways of doing things, because the same old ways aren't going to work. And this is true in our social world, and it's true in our engineering world. And so this is why I like what I do. I mean, the truth of the matter is, I don't do engineering anymore. But one of the other things that engineering does is it gives you a methodical way of approaching any problem that comes before you. And with the degree in engineering and the schooling that goes behind it, you can set yourself up very well to succeed, whether you choose to continue to be an engineer or whether you choose to go on into a different field. You know, my engineering path changed dramatically. I became an engineer because my father was an engineer. And, you know, I used to do things with him, like we built a deck, and he would put, you know, a diagonal support up, and I'd be like, why are we doing that? And he'd explain to me about the support, and I thought it was really cool that he knew all these things. And then when I got into high school, I liked cars a lot, and I wanted to design cars. So and then I got to college, and I figured out that designing cars isn't really so much about drawing cool pictures as it is about what size bolt do you use to put them together, and, you know, what kind of steel and how many threads per inch and some things like that. And it just wasn't for me. It is for some people. It wasn't for me. The analysis side that I described in my presentation was for me. For me, it's kind of like an investigation, where I can look at this design and figure out, is it right or is it not right? And again, I know at the end of the day, I'm making an impact on safety, so it means something to me. And then, after doing that for a while, though, I decided I liked the policy side of things, and so I moved out of engineering. But my engineering degree and the education that got me has really served me well as I move through my career. So again, I think that there's a lot to this. I think that we always have to challenge what it is we're doing and why we're doing it. And engineering is a field of endeavor in which you have almost limitless freedom to do that. So thank you very much.